Okay, hi, my name is Thomas Schlumbrecht. I am one of the teachers of Math151. Please forgive me, this is the first time I'm doing such a video and I'm a little bit nervous about it. So, the purpose of today is to try to answer the question, what is calculus? So, this is part of mathematics, which was introduced at the end of the 17th and beginning of the 18th century, mostly by Isaac Newton and Leibniz. And what does it do? So, let's start before calculus. There are things which we can compute using algebra. Well, what does it mean using algebra? Algebra, we only use addition, subtraction, multiplication, and division. Okay? And what are the things we can compute with algebra? It's, for example, the area of a rectangle, A times B. The area of a triangle, if the base is this is the height. The area is 1/2 of the height times the base. Sorry, this is a B. And for example, the area of a circle, so with a radius r, so this should be the area is pi times r squared. So these are typical things we can compute using algebra: addition, subtraction, multiplication, and division. Okay, another thing which can be computed using algebra is, for example, average speed. Average or velocity. So, for example, a stone is dropped at the height of 200 meters, and the height at time t, so at time 0, and then the height as a function of time can be then computed to be 200 minus 4.9, this is half of the acceleration, times t squared, and this is in meter. Okay, so what is the average velocity between the time, between t equals to 1 and I think t equals to 3. So t1 and t2 equals to 3. Well, we all know what we have to do by doing that. We have to look at the height at time 3, subtract the time at the height at the time 1, and divide by the difference of the time 3 and 1, by 2. And then if you compute this, it is equal to 200 minus 4.9 times 3 squared minus 200 minus 4.9 of 1 squared, which is, of course, 1, divided by 2. Now, if you compute this with your calculator or so, this will be then minus 19.6 meter per second. So we simply computed this average velocity by using differences and division. Something else which can be computed using algebra is slopes, is the slope of a function. So consider f of x, I give an example, equals to 1/2 of x squared. Let me make a picture. So I'm only interested for the moment in the positive part. So this is 1, 2, 3, 4. 1, 3, 4. 1, 2. At the point 1, it's 1/2, so the function looks like that. So, and what do I want? I want the slope of the secant between the point. So we want the slope of the secant between the point, well, 2 points at the curve. At the point A, which is the point 1, 1/2, and the point B, which is the point 3, and at the point 3, it's 9 times 1/2, it's 4.5. So this is the point here. This is the point A, and the point 3 is this here. This is the point B. And what is the secant? The secant is the line which goes through these 2 points. Sorry. And we want to have the slope of the secant, and this is always the change of the x, the change of the y, divided by the change of the x. So this is the delta y, and this is the delta x. So the slope, slope is then the change of the y divided by the change of the x, which is the change of the x is 3 minus 1. And the y is 1/2 at A and 4.5 at B. So it's 4.5 minus 0.5. And this happens to be 2. OK. So I gave you now several examples of things which simply can be computed algebraically, meaning by addition, subtraction, and division and multiplication. So now we get to objects which cannot be computed by algebra. So, for example, let's take an arbitrary function. Let's take 2 points A, and let's 2 point B, another point B, and look at the area below the graph. This is something which cannot be computed using algebra. Another thing is, take a function. So here the area. And let's take not a secant, let's take a tangent. So tangent. Here we only have 1 point, and if you have only 1 point of a line, you cannot compute its slope. You don't have enough information to compute its slope. So what is the slope of the tangent? So this is 2 typical things which there's no algebraic way to compute it. But, and this is the important thing, these objects can be computed approximatively. Approximately. Okay, how? For example, the area, we can approximate it by rectangles. And of course, if you think about the finer you make these rectangles, the better you can approximate the area. So you can compute the area up to some error. The errors are always in these little areas outside. you can use rectangles to compute this area approximately. Here with a tangent, we can also do, we can look at secants through another point. So if this is A, this is B, and then let the point B closer and closer to get to A, and you might imagine that if I let the point B go closer and closer to A, the secant becomes closer and closer what we think the tangent should be. Okay, I said some things cannot be computed algebraically, but they can be computed they can be computed approximatively. So now the purpose of calculus, compute certain terms approximatively let me make this in parentheses, and then now comes the big thing of calculus, take the limit. So this is really the most important thing in calculus, taking the limit. In other words, getting better and better approximations, and then you think what happens eventually. Let me describe this at the end in a very easy example. So, what I mean by that, and this will be the object you will be fighting with during the whole semester, what taking the limit means. So here, an example. We consider the function f of x equals to x squared minus 9 divided by x minus 3. And as you can see, since the denominator never should be 0, we can only define the function for values which are not equal to 3. So, we cannot compute the function at x equals to 3. But we wonder what happens if x gets closer to 3 without being 3, without equaling 3. Right? What happens with the function value f of x if x squared minus 9 divided by x minus 3? What happens to this function value if x is getting closer and closer to 3 without being equal to 3? Well, we can make a little table. We can compute this. Let's see. We put here the x value and compute the f of x value. So if you put, for example, x equals to 7, we got f of x being 7. If we put 3.1, we get 6.1. If we put 2.9, so from the other side, we get 5.9. And then we put 3.01, we get 6.01. So you kind of think the closer and closer x gets to 3, the closer and closer f of x gets to the number 6. So the guess is f of x gets closer and closer to the value to 6 if x gets closer to 3. And actually we can very easily see that because, you know, we can write f of x, we can factor the denominator. If you remember the formula a squared minus b squared, it's the same as a plus b times a minus b. So we have here x squared minus 3 squared is equal to x minus 3 times x plus 3. So we can write it as x minus 3 times x plus 3. But now we can say, I never let x to be equal to 3. So this is a x minus 3 is a number not 0. So you can cancel it. So this is x plus 3. Now, if you look at x plus 3, of course, you understand if x gets closer and closer to 3, this goes to 6. If x goes to 3. So this was an easy example where we can kind of see what happens with the limit of f of x. So we write, and this will be introduced in a more formal way in the next section, that the limit of x approaching 3 of f of x equals to 6 in this case.